Simple interest versus compound interest, financial introduction. Okay, so this is what we set up in the last video. We've got in the purple, we've got our recurrence relationships for simple interest on the left and for compound interest in the right. And in the green boxes, we've got those ways of calculating a much higher term without having to work out the previous terms. But now I'm going to introduce some new terminology. So we're going to talk about the idea of principal. So P equals the principal. Same spelling as for the teacher in charge of all the other teachers at a school. So P is the principal. Now P is the blue bit. The blue bit here is the principal, and that's really what you've borrowed or what you deposit at the bank. So that's your starting point. So we can actually say V0 also equals P. Okay, so make sure that looks like a P, and that equals P. And these green bits are actually your interest. So we're going to say I equals the interest. So this is I, these are all I. Now I changes depending on what you got here. If you've got simple interest or compound interest or how many times this has happened, but they're all called I. So that's the amount of interest. And then what this here is the amount that you owe. Okay, so that's the A. So imagine you've borrowed money from the bank. Then what you owe is the principal plus the interest, isn't it? So that's all of that is A. All of that is A. And as you can see, A is getting bigger. If you've borrowed money from the bank, then that's not good because you owe more money. But if you've deposited money in the bank, you've got more money. Though interest rates are very low for that at the moment. Okay, so you can see that's the total is we call the amount. So A equals, I'm going to call that the amount. Think of it as just the total. And so what you're actually finding is, if we look at those green formulas, they sort of relate to that. So we were saying like the amount you owe is actually the principal, which we know is V0, plus some interest. So you can see there's a difference in how you calculate interest here. You've got ND. And then over here, you've got the same thing as A, the amount equals the principal plus the interest. And it might be a bit hidden how that one works. So what we're going to go through the next couple of slides is explaining what this means. So for both situations, you owe an amount, and that's calculated. There's a principal and a interest amount that you need to combine together. And it's very important in a question, because a common mistake in questions is, did the question ask you to give the amount or the amount of interest? Now, I just want to compare some of the numbers here to show you what's going on here. So remember, the principal doesn't change. So here we've got the principal, and it's always 10,000. It says 10,000 here, and it's 10,000 at the end. And for compound interest, 10,000 at the start, 10,000 at the end. But what you notice is that, and as I said, simple interest just chugs along at the same rate. It's always adding 1,200. But this guy is really accelerating, you can see. So by the time we get down to our term 10 here, like after 10 time periods, we've got 12,000 in interest to give us a total of 22,000. But after 10 time periods, we've actually got $21,000 in interest. So you can see like the majority of what you owe is now interest. So that you actually, if you've borrowed $10,000 from the bank, you now owe $31,058.48. So you can see that the compounding really does make a massive difference. Notice also, I've been very good about using 2 decimal places, and again, 1 cent and 2 cents do exist still on computers and on answers for exams. So it's just good to look at the numbers, comparing between these, what's the same, what's different, and you can see that very quickly there's only a small difference, like the interest, there's no interest at the beginning, it's still 0, and your first time period is always the same as the first time period, and the second time period, only a little bit of a difference there, but by the time we get down to this 10, there's a massive difference there, and that's why people love compound interest. Okay, so interest and interest rate are often confused, so it's a good point to spell out the difference right here, right now. So interest is an amount. It has a symbol I, and it always is an amount in dollars. So you might say, oh, my interest is $1,200. Yeah. Whereas interest rate is given the symbol little r, notice that's little r, and percentage. And it's not just percentage, it's percentage PA, which means per annum. So I just want to spell that out. So this is percent. Now per is Latin for divide, and cent, that's Latin for 100. And this is the same thing. This is per annum. So this is per annum. So this is per means divide, and annum means year. So you might see an interest rate written as, say, 12% PA, so 12% per annum. So you often see in the formulas then that you'll get this R over 100, and so this percent becomes per cent. All right, so a lot of people realize that literally percent means divide by 100. But then we have to take into account this per annum. Now, you might have a quote of 12% per annum, but you might not be compounding or making your interest payments every year. You might be doing it more frequently than that. That's quite a common thing. So you might get this idea of n. Okay, so n, this little n, is the number of, well, installment, we'll call it, installments in a year. So, so if it's yearly, then we get n equals 1. And then you might have quarterly. In that case, n equals 4 because there's 4 quarters in a year. You might have monthly, in which case n equals 12. Fortnightly. This is a very British thing to say, fortnightly. Americans don't say it, but there's 26 fortnights in a year. A fortnight is 2 weeks. So I'll put that in little brackets. Fortnightly, so that's 2 weeks. There are roughly 26 fortnights in a year. And then you might have weekly, in which case n equals 52. And then you could even have daily if you wanted to. Daily. And that would be n equals 365. Don't worry if they don't actually equal that. I mean, like, obviously there's actually 365.24 days in a year, but that's the numbers that you use in accounting. So you might actually find that not only do you have to take the rate and divide by 100, you might actually have to divide that by n. So whenever you see this n happening into your formulas, there's a reason for that n, and that n is because you've been quoted yearly, but you're actually going to be paying it in a number of installments of 12 in a year. So if you imagine, if I'm doing 12% per annum, but I'm doing it monthly, then it'll be 12 over 100 divided by 12, which equals 0.01. That's the actual number you use in the formula, because this is for monthly, if I was doing monthly. So interest is an amount in dollars, has the capital I, but interest rate is little r, and it's given as a percentage per annum. And in formulas, they'll start sticking this n in, and that n is just to take into account the fact that, like, you're not actually doing it yearly. If it is yearly, then you get n equals 1 and it just disappears. All right, so let's look at simple interest. Now, we said that this is P in our principal, and then we said this thing is I. So this is I, this is I, this is I, and this is I. And then we said all of that is A. So all of that is A. So the principal plus the interest. Of course, you've got the V naught. You've got no interest, so it's principal's the same as A. So that's your A, that's your A, and that's your A. Now, we're going to look at then using R to calculate I and D that we've talked about before. So we had the equation before, V naught equals 10,000. and then we said Vn plus 1 equals Vn plus D, and we just told you it said Vn plus 1200. We're going to look at calculating. So we're going to look at calculating D, this 1200. Where did that come from? And then we had the other formula, which was that Vn equals V naught plus ND. And so we look at all of the ways to calculate these things. And again, the comparison with that is that basically A equals V naught is the principal plus the I. All right, so you can see how the two things compare, that ND is actually the same as I in this case. And so we need to actually make some maths on that. Okay, it's probably easy to do this with a table of values rather than trying to read off the graph because it's not so precise. Now we had a formula before that Vn plus 1 equals Vn plus D. So if we want to find D, we can just rearrange this. D equals Vn plus 1 minus Vn. And let's remind ourselves what V and Vn and all that kind of things are. So this is the next term, and this is the current term. All right, and so we can grab any pair of values that work. Be careful because that's number 10, so 5 and 10 are not consecutive, but two consecutive terms. So let's grab these two. And so this is V1 and V2. So we can say D equals Vn plus 1 minus Vn, which equals V2 minus V1, which equals 12,400 minus 11,200, and that equals 1,200. And I'm going to be good and put a dollar sign at the front. And that worked. But I could grab any other pair. I could grab these two down here. And that's V4 and V5. So D equals Vn plus 1 minus Vn, which is V5 minus V4, which is 16,000 minus 14,800. And that does, in fact, equal exactly the same, because we said the D doesn't change on these things. That's one way of doing this. But I'm going to give you some extra information here. I'm going to tell you actually, if I didn't give you this, I could give you that the interest rate equals 12% PA. All right, I'm going to assume the time is actually years here. That'll save us a bit of effort here. So we don't have to worry about N in this situation. So we can actually write a formula that the D equals the rate, which is 12%, remember, divide by 100%, times the principal, which is V naught, or principal. You know the same thing. So this would just equal 12, because it said 12% per annum, over 100, and our V naught was 10,000, because that's our V naught there. So times 10,000. And if you do all that things, you should get 0.12 times 10,000, which does in fact equal $1,200. All right, so there's a new formula for you here. We've got a couple to do there. We've got this formula here for D, and we've got this formula here for D for simple interest. So we must highlight that. These are the formulas for simple interest. Okay. Vn equals V naught plus n lots of D. That was when we were doing the rule for recursion. But we've also found that the D equals R over 100 times V naught. Not forgetting that we said R in this case is 12% PA. Now, what we're going to do now is we're going to take this D and substitute it into here. So we end up with the formula Vn equals V naught plus NR V naught over 100. That's still in recursive notation. and this is where you might get a bit confused. So remember, we also said that the amount you owe equals the principal plus the interest. So we can say Vn is A, V0 is P, so V0 is P, and this is where it gets a bit annoying. The N is now going to be T, okay? But we've got to take into account that the interest rate, remember the interest rate is per annum over here. So to calculate that, we use N again. It's annoying. It is N. They're going to say N, but we have a little N down here. So let's just highlight these formulas, the ones you actually need to be using here, so that you don't forget. This is an important formula, which we can also write as A equals P plus PRT over 100 N. And that's another important formula. So I'll put a box around that. And what I'm going to do is actually label that up so you know exactly what I'm talking about. So P, that's the principal. And R, that's the interest rate. And I'm going to say per annum. All right, so that's a very important thing. There's PA, okay? And then what I'm saying is, what is T? T is the years. Okay, how many years you're doing this? And then this is why it gets confusing, because this N is a different N. I'll do that in black here. So that's N. That N depends on whether it's yearly equals 1. Remember we said that yearly equals 1, or monthly equals 12, you know, and quarterly equals 4. So, you know, whatever that is, it depends on the value. And that gives you all your formulas. Some textbooks will rearrange this, so you might end up with A equals P times 1 plus plus RT over 100 N. That's a little r there. That's the same thing, it's just being rearranged. And I'll give you another formula that, remember that the PRT over 100N is I, so just I equals PRT over 100N, and that's another little formula that you might want to use. Okay. Okay, so this is compound interest, and we know this is the principal. And we know this is the interest, our I. So we already know that like the principal is the same as V naught. And so we're going to look at is how to calculate this R that we got is 1.12. Now we do know, of course, that the amount we owe over here, this amount is just the same. That it's always the principal plus the interest. That was that formula we got over here, that the amount equals the principal plus interest. But you can see it doesn't really relate to this formula. So when you want to work out what I or the amount are, almost all of this, you'll see Financial Solver. You pay $200 for a calculator. Guess what? It's going to do all the work for you. So let the Financial Solver do all the work for you on this. Now, what I want to emphasize here is, though, that why is it that compound interest does this sort of curving up and accelerating? And the reason it does that is that when you're doing simple interest, you're calculating the interest just off the principal. But when you're doing compound interest, the interest here is calculated off the principal, but the interest on, say, term 2 is calculated off A. And then the interest in term 3 is calculated off all of that. So what you're actually doing is charging interest on interest rather than just interest on the principal. And that's why it tends to accelerate. All right. So we did have the formula Vn plus 1 equals RVn. Rearranging that, you get R, which means ratio, ratios are just another way of writing fractions. So it's Vn plus 1 over Vn. And that's a formula that you can stick in your books. So let's have a go. If we just grab any pair of numbers, let's just grab this pair of numbers, and that's obviously V2 and V3. We can say that R equals Vn plus 1 over Vn, which equals V3 over V2. Remember, fractions are division, so it's 14049.28 divided by 12544.00, and you should roughly get 1.12. And as I said, we can do any pair of numbers, so let's just grab those two numbers, and it'll be the same thing. This is V4 and V5. So let's just do a little space over here. R equals Vn plus 1 over Vn equals V5 over V4 equals 17623.42 divided by 15735.19, and that equals 1.12 to 2 decimal places. Well, that's fairly straightforward, isn't it? Now, you might remember, though, that we said little r equals 12% per annum. And lo and behold, there seems to be some weird connection, because this says 12 and this says 12 over here, and we've got a 12 over here. Well, that's pretty good, isn't it? So what is causing that? Well, there's another formula for you, that big R equals 1 plus R over 100. And that's a fairly straightforward formula to use. So if we just said, R equals 1 plus 12 over 100, and so that does in fact equal 1.12, exactly what we said before. So that's how you work out what R is. There's two formulas and two ways to work that out. So we did say that Vn equals R to the n V naught. But we also said R equals 1 plus R over 100. So we can take this formula and stick it in there. And that gives us that Vn equals 1 plus R over 100 to the power n V naught. But we know that Vn is the amount we owe and V naught is the principal. And we have to change our terminology to make that T for time, and we have to put the N in. So what we end up with is a formula that looks a bit more like this. So we say the amount we owe equals the principal times 1 plus R over 100 N to the power N T. Now I've just got to explain all that and label all that up so that makes more sense. So this N, it's the same N, same amount. That's your yearly equals 1, or your monthly equals 12, or weekly equals 52. Sorry, 52. That's that value, and that changes depending on the thing. And then what's T? T is years. Okay. And R is the interest rate per annum. Now, before you just look at that and go, I hate all this. See this lovely little formula here, which is looking very, very horrible for most of you. I'm going to say those magical words that see Financial Solver. I am not going to ask you to type that into your calculator. Some textbooks like to make you do that for a little bit of practice, and then you have to go to the Financial Solver. Just do it on the Financial Solver. That's what you have to do. Okay, for both simple interest and compound interest, it is true that the amount you owe is the principal plus the interest. The difference is with simple interest, you're calculating the interest just off the principal, but with compound interest, you're calculating the interest off the amount, which is the principal plus the interest, so you're getting interest on interest. So for both of them, V naught equals P for the principal. So let's just label things. P is the principal. And R, little r, that is the interest rate. And that's as a percentage PA. All right, that's why we have to do the divide by 100. And then T is years. And this is true for the same thing over here. So it's, so that is also years as well, and that's the interest rate as a percentage PA. So they're the same thing, they're all parallel. And then N, I'm going to, well, first of all, try and find a light blue. So N is the number per year. So remember, so for yearly equals 1, and then you can have quarterly. Quarterly equals 4, and monthly equals 12, and then fortnightly equals 26, and weekly equals 52. And that's the formulas for these things. You might notice some lovely phrases here. So to be honest, this formula here and the interest rate over here, I've said see Financial Solver. So that'll be a lot easier for you to work out, and there's no reason why you should not just use the Financial Solver for these things, because you paid a lot of money for a calculator to do all the work for you. Why not make it do the work? And we did have one other little formula, that R equals 1 plus little r over 100. We also had a couple other formulas to put in there. We did actually also say that D equals Vn plus 1 minus Vn, and we also had that R equals Vn plus 1 over Vn. So that should cover most of the formulas you need to know. And again, cannot emphasize enough that these dudes here is Financial Solver. So don't panic about those. Just learn to press the buttons calculators in another video.